RZ. My name's Stan, and today we're working on an oven. It's a little oven that I bought some years ago. It's entry level for sure. It's made by the Tabletop Furnace Corporation, and there are some things that I've always hated about it, and I'm going to go over all those things I hated about it with you. And I had a failure, and I was ready to do the SSR went out in the controls, which is an easy fix. We got the control group off of it, and while I had it apart, I went ahead and disassembled the entire oven. You know, the oven's always been too small, and my sizes are the original size OD of the oven. These are all in inches. Was 6 deep, 8 high, 6 wide. My new dimensions are going to be 12 deep, 10 high, 12 wide. That's going to, the old ID of the thing was 5 inches deep, 6 inches high, 5 inches wide was the interior dimensions. My new interior dimensions are going to be 10 inches deep, 6 inches high, same height, not changing, and then the same width. We're not changing the width or the height, I'm just changing the depth, that's it. All right, but what I am doing is we're adding some insulation. Now they use the refractory element. This is a refractory element, which I use in, you know, in big industrial bake ovens, but they only use 1 inch of it. Not very thick, real easy to work with. You can cut it with a bread knife. But they only had 1 inch of it in there, so I'm bumping up. That's why you heard those dimensions I just was talking about. The OD went way up, so it's 2 inches bigger in all directions. So we gutted it. There's the old shell of the oven there, and you can see these guys make theirs, and you can just see all the discoloration and the corrosion and everything. They don't make them out of stainless or anything. It's just, when it comes to you, it's just black steel, and then this is the kind of rust you get from moisture and burning off all the oils and everything. So we're redoing all of this. I've got a drawing for the can right here. The door, here's the door. 1 inch thick, and they just had a single layer of kale wool. So we're gonna make a new door with a nice thick. We're probably gonna stick with the kale wool, which I'm okay with, but we're probably gonna go with a block of the refractory element and then the kale wool over that. So we're gonna make a 2 inch thick door, and the whole oven we're gonna build it 2 inches thick. A little deeper, we're changing it from 5 inches deep working depth to 10 inches. So we're getting quite a bit of depth in there, and big enough to get some parts in there. You know, I fill this thing to capacity all the time, and it heats it fine. Now I did take an ohms reading. Here's my element here with an ohm meter on it. And I did a little bit of calculations, and I arrived at what I've come up with is I'm still going to be able to make my temperature even with the larger oven. Time will tell whether I have to change out the element, but I did some initial calculations, and I need to get to between 15 and 1700 degrees inside this oven. So I used to make 2200 no problem. So the extra capacity or the extra size, I don't think is going to affect it. I think we're still going to make target temp. Now, a few things we are going to get rid of that I hate. They had this horrible little latch on the door, which actually took 2 hands. And usually you've got a pair of pliers in one hand, and you're opening a door and you're pulling parts out, and you need to be able to work that door with one hand. So this latch is going see you later, bye. And then we're getting rid of the corrosion problem. We're doing that basically by insulating, by giving it 2 inches of wrap all the way around instead of 1. I think we're going to make all this corrosion problem go away. I'm going to use a pre-coated powder coated material for the exterior of it. And then, so lose the latch, double insulate, lose the corrosion, and up the capacity. And I think we're going to be in good shape. I think I'm going to be happy with this little tabletop oven after that. No one offers this in the size that that I'm building. You know, there's no such oven as this. So I'm building me a white elephant. All right, but we're just kind of revamping what's already there. Like I say, I've got refractory element, I've got candle wool, I got sheet metal, I got a brake, I got a shear. Why not make our own oven? All right, let's bring you in. I'll show you the drawing as compared to the actual oven shell here. All right. Okay, well, every job starts with a plan, and here we got a plan. Here's all our dimensions on our 3 brakes. What we're making is the main oven shell. It was that 3-sided box that I showed you. But we've upped the dimensions here to 12, 10, 12. We've got our 45 V notches and all our break points. We've got a 34-inch overall length, and we've got a 12-inch overall length on our little 1-inch tabs on the side, just as a refresher. And I'll show you the profile of that, and I'll show you how that profiles on the box. Okay. But there's our 45 notch corners there and there. All right. So we're getting rid of that nasty rusty thing, and we're going to make ourselves a fresh one. Here's our original ID and OD. Here's our new ID and OD. So we've got a plan, and we're ready to lay it out on sheet metal and bend it up. Here's that door latch I was talking about. Just a horrible little thing. And like I say, it takes 2 hands to operate it. You gotta flip this open and pull this bail back, because the bail always gets caught on the little hook, and it always takes 2 hands to operate. Not convenient at all. So that's going, see you later, bye. And you know, making some other improvements kind of as we go. All right, so let's get the sheet metal laid out. Okay, I thought I'd show you a trick for doing corner notches. What we've got is a 1-inch back set. We've got a cross line, and this is our break line. So we want our corner notch to be right here. What you do, and we've got 2 scribes already there. What you can do with this, you can fish around with your scribe, and you can feel it drop right into that intersection on X and Y. So you're already in place, and you just take your square, drop it on there, run it up till you can feel it bump into the actual scribe, and then just make your line without ever moving your scribe. And you know you've got a perfect intersection right to your T-junction. All right, so that's a way to, let me get this camera out of my way and I'll do the other side. Once again, fish around. You'll feel it drop right in. Bring your square in, bump, scribe your line. Alright, easy as that. Okay, so the sheet metal's marked. We've got all our break points marked. Even right here where our corner notches come in. So we're marked here, here, here. You know, everywhere we've got a break, we're marked. And now you can see why I get this material for free. It's the kind with a plastic coating on it, and when the stuff comes in, people have picky fingers. These are the same people that pick beer labels, and they peel the coating off, and then they get scratched up during the installation, and the customer doesn't like it. So we get new panels, and that's how Stan gets powder coated sheet metal for free. So there's that side. So I'm going to choose that one to be the outside because it's the best looking one. There's a few scratches, but it'll do. It's good enough for who it's for. All right, let's go over to the brake, get it set up, and we'll go ahead and bend this box up. Okay, so we're adjusting the brake for this material right here. This is 18 gauge, and what we want is the tip of this brake die. We want it right out even with the apron. So we want when the sheet metal is installed, we want our sheet metal way out here. So we're adjusting the upper out in this direction. So pretty easy to do. Just use a piece of scrap sheet metal, and on the Chicago, it's just a matter of a couple jacking bolts. And you can see that moving out, but she is definitely moving out. Like I say, I'm just putting the sheet metal there until I see that apron brake just disappear. And we do this on the left and on the right, and that's right where I want it, right there. So we're gonna lock this side down, and then move to the other side, do the same thing over there, and then we're ready to bend. I had 10 gauge in here before, so I had a pretty thick material, and you have to adjust your upper every time you change material thicknesses. Okay, well, we've got our piece and we're ready to bend away. We've got a full leaf. We've got our back spacing adjusted on the dies, and we're just going line to line because we didn't leave any bend allowance at all. We're going right on our scribe lines, right up to the die, all the way along. And we're going to pull and pinch that sucker in, make sure the camera's still good. Okay, let me move it just a little bit. That counterweight kind of got in there on you. And we're ready to pull. And we're just going to pull it up to the stop. And that's that. Let me move the camera. It was really close to that counterweight. Okay, here's another view. So all we're going to do now is take the whole thing, and we're going to open up the head a little bit so we can get this piece all the way in there. There's tons of room behind these dies. After you get back about 4 inches, it takes a big step up. So there's lots of room to get your returns in there. So we're going to come down and get us in the ballpark here. And if you're doing multiple pieces, you'd set up a back stop or a front stop. You've got stops that can come off of the front. You've got stops that can go out and back. I'm happy there. Okay. Yep. All right, looking good. 90 degrees. And we hit our 90-degree stop. And now we've got kind of a channel looking thing, but we need to do 2 more bends, and that's just going to be a matter of sticking it in like this. We need to find where we've got the real estate for that on these dies. I think 3 little ones will probably do it. Let me switch some dies around and see if we can make that happen. Pardon my arm. And we're just going to take this dude right to there. This is actually a pretty easy bend, but we're going to bring this up to 90. Okay. Then we're going to flip. And bring this guy up 90. And there you have it. One oven. Well, you can certainly see the difference in the oven box profiles. There's the old one. There's the new one. So you can certainly see we've definitely made a size increase. Mainly due to the extra insulation. You notice it is quite a bit deeper, so it is, I can get my bigger parts in there just fine, but it's mainly due to all the extra insulation that I'm adding to it, because we're going to have 2-inch walls instead of 1-inch walls. So it grew 2 inches in all directions on the OD, and that box reflects that. Alrighty, I just thought I'd bring you in for a quick how-to on that. Okay, well, we've got our legs drawn, if you want to call it that. These are the side plates for the oven. Now, remember, our oven OD has changed, so we've got a 12-inch width, and these 3 pencil lines indicate break lines. And we're going to be doing a double return with a single reverse bend. So this is kind of a reverse setup, and then you got two double returns. 1, 2. 2 doubles. That would be 4, right? No, it's just a double return, not a double. All right, so it's got a double return with a single little reverse bend, 1/2 inch by 1 by 1, 14-inch side plate, and that's all reflected here. So that gives me my layout size. So we need 2 of these, so we can go cut up the stock and start laying out our brake lines. All right. Okay, we're done shearing everything up, and we've got 2 scribe lines here, and on this side, and they're set at 14 and 15 inches. And remember, we're doing a reverse bend, so we do one more scribe line on the opposite side at 16. So we're ready to bend. All we have to do is set up the brake to do this reverse bend. Okay, so if you've got a Chicago brake, you already know that all the apron dies are just pieces of angle iron, and this is a piece of a 2 by 1. So that we're going to use the 1 inch up on the work side, and the 2 inch just drops in to the actual apron. Now, a lot of times you have to take and just mill down a little section of it, and, get it on the mill and measure it real careful, so it drops into the apron properly. But it's no big deal to make your own dies. And don't forget your Chicago has got reverse screws, and the die just kind of lifts right out like that. So that's a piece of 2 by 2 that I use for a die. And I've got different sizes. You can even make, let me show you another profile I made. This is just a piece of 3/16 flat bar, and that gives you a little tiny 3/16 die right there if you got a real tight reverse bend to do or something. So that's it's real easy to make your own dies for your machine. Anyways, let's get the 1 inchers in there. Come on, there you go. And you just got to make sure they're seated all the way down and everything's flat across here. Outside of that, it's nothing to it. And then tighten all your clamp bolts. There it is. Okay. All right, let's get to bending up our piece. I did tell you that it's important which bend you do first. We're going to start with the little 1/2 inch reverse bend. That's right out of the gate. I'm doing that one first and foremost. All right, ready for that? Coming up to 90. Now we're going to flip, and this is where we need the 1 inch die, because all we're going to do now is just take and go bump and bump that in. If you've cut your die accurately and milled it down, you can use this as a stop against your right up against the face of your die. If you're using raw angle iron, don't trust it. But there you go, 1 inch, 90 degrees. And then again, out to your lines, 90 degrees. And there's our profile. Okay, that's what we're looking for. Okay, nothing like changing your boats midstream. When we started off, these were longer. I went ahead and cut them off, but I had this up kind of high with my control down at the bottom, and I've always hated the control at the bottom. So I went ahead and cut them down to make it sit as so. So those returns act as kind of legs and create an air gap under the oven, so it doesn't heat up the tabletop. So that's totally fine. And my little control here, I'm just going to mount it off to the side. Probably going to build a new control box and just put it kind of sideways over there. just always hated it at the bottom, and you can actually see the temperature controller got a little melted up here. I was pulling something out of the oven and I dripped something on it or dropped a red hot piece of metal on it or something. So it's always been in harm's way. So we're going to try to keep it out of harm's way. So I changed my design a little bit, and I did cut these side plates down, so it just I'm not going to have the control underneath the oven anymore. But that's how the whole thing, that's how the box looks now. All right. And I'm going to just keep pushing forward. We're going to go ahead and make a door to fit that right there. And then we'll probably make a new control box. Get rid of that little turkey there. Okay, so we got our oven tacked together. We just got it together with some screws. These little tiny lathing type screws. And we've got our refractory element, and you can see it's keyed, and none of my seams line up. And that's the key to doing this kind of stuff. You don't want the seams to line up, so you've got a path through. The floor is going to be a refractory brick, just one brick that slips in there, and I'll be able to drill holes in it and put some pegs in there to hold my parts straight. So the floor is not going to be this spongy refractory element. This stuff's pretty soft. Fairly easy to work with. You can just cut it on the bandsaw. But we're all 2 inches thick now all the way around, and you can see the size of our oven's pretty big compared to our old one. So there's the old box compared to the new box. So we've got an extra, extra layer of insulation. And next up is a door. The old door was 1 inch thick. We're going to build a 2-inch door. And you see we're not even close to fitting here. And you can see the heat was really coming through this thing. And what they had is they built this door in one piece, and they just used KO wool. I'm probably going to build mine in 2 pieces and build it with 3 sides, make the bottom come off to make it easier to get the insulation in, and make the bottom channel removable. But there you can kind of see that the heat was really coming through this door. This thing ran so hot there's no way you could touch the outside of this oven without gloves on. It was just way too hot. Here's a refractory element I wanted to show you. It's really light and it just breaks. It's like styrofoam almost. So that's how easy it breaks and shatters and everything. It is a natural product. It's like a mineral. It's a silica base, so there's rock in it. So whatever you cut this stuff with is going to get torn up. Bandsaw blade, whatever. It's really going to tear up your bandsaw blades. You can cut it with a bread knife too, with a serrated bread knife, but it's going to tear up your knife blade. All right, but that's that element inside of there. But I didn't want to use that soft element for the floor because you're always putting parts in there and dragging them in and out, and the floor was really getting torn up on the old oven. So I'm going to use an actual fire brick for the base, and I'll probably they're only 1.5 inches thick. I'll probably back it up with some with a sheet of KO wool. I'll put a loose sheet of KO wool in there and set the brick on top of it. All right, but that's going to be my floor. Okay, well, here we are with the door. We've got the old one here, and you can see it's a 4-sided box. And I was going to go ahead and duplicate that and just make. The wind just kicked up out of nowhere. I was going to go ahead and make a 4-sided box to suit, with the larger dimension, obviously. But then I started thinking, how am I going to get the insulation in there? Getting it in the door is no picnic at all. So I'm thinking I want to build the door in 2 pieces. So I'll build 3 sides with the, with the double return on it, and then just leave a loose channel at the bottom of the door to slip in there and screw it in or pop it in later to retain the insulation. So I think I'm going to just change my plan a little bit. We are building the door 10 1/4 square on the OD, and we're building the door 2 inches thick to accommodate the insulation. All right, and there's the profile of the door. That is a double return. All right, so let's get started and get it sheared up and bent up. Okay, here's another little tip for you. If you're doing equal sides, if both sides are equal, and you have to do a little 45 notch on each one where the double return comes together, lay your square on there. Your tips of your corners should intersect here and here, both places. Scribe one line, and as long as you've got it scribed out like that, just go ahead and take it over to the shear. If you don't have a corner notcher, take it over to the shear right now and just lob off that corner straight along that line. It'll be that much less that you have to cut out with the corner notcher. Actually, here, I'll show you. So I can put this in a spot where it's not gonna come down on you when I stomp the shear. And just lay your line on that bottom shear. And just make sure it's gonna hit your scribe line. And that's it. Straight across like that. Now all you got left to do is get in there and get that out. And I don't have a corner notcher, so I got to do that by hand. All right. Okay, we got our piece done. You can see our corner notches with our little 45s in there. Those are no big deal with a pair of hand shears, and then you dress it up with a file a little bit. Get in there and just cut it a little short, and then file it right up to your scribe line. All right, and I've already got a couple jaws removed down there, so we can do our last bend. We're going to do first, second, third. Our last one is going to be the one that closes the box. So let's get this turkey started. And that's how our corners turned out right there. Okay. So that's why we mitered those. Okay, guys. Well, that's the end of this video. Our video's running long, so we don't have time to get the control group in there. But that's the sheet metal work. We got our door finished, you know. So I got to come up with a hinge for that and a latch, and I'll show those in the next video. And I wanted to warn you about the refractory element or the insulating fire brick. You know, it works really easy. It bandsaws, it cuts, it files, it sands, it does everything really nice. But don't breathe it. It's a silica-based product, and it can really irritate your lungs. So don't wear respiratory protection if you're going to work with it, all right? I hope you enjoyed this segment. We're going to find out whether the powder-coated material was a mistake, whether that powder coat re-gels every time the oven gets hot. We'll see what the outside temperature is. I'm hoping it's less than this. With a 1-inch installation, my outside temps were in the 500 to 600 range. So that's why it burned off all the oil, and you couldn't even touch the thing. It was just so hot on the outside. So I'm hoping that extra insulation is going to take care of it, and see if I should have made it out of stainless. We'll see here in the near future. We'll get some temperature readings and see if I got to make it all over again. All right. Appreciate you guys tuning in, and we'll see you on the next one. Oh, nothing like changing changing your plan midstream. I changed my mind. I built the legs, and these were, you know, the boxer.